Hi guys. What we're going to be focusing on today is taking a little bit of a closer look on Newton's second law. If you remember, Newton's second law is force equals mass times acceleration. So what we're going to be doing today is we're going to be kind of looking specifically at the components in that particular equation. So we're going to be talking about force, we're going to be talking about mass, and we're going to be talking about acceleration. Alright, imagine if we go ahead and take these two items. Notice they're about the same size, same shape, but the one thing that's different is one has more mass than the other. Now imagine if I went ahead and put them same height and dropped them at the same time. What do you think would happen? Make your prediction. Hopefully you made your prediction, and now what we're going to do is we're going to take a look and see what other people thought as well as what actually happens.
Left hand, I have a standard sized basketball, and in my right hand, a 5-kilogram medicine ball. If I drop them both at exactly the same time, which one will hit the ground first?
This is a trick one, isn't it?
The heavy will go down first.
Well, yeah, it'll drop faster.
They'll both hit the ground at the same time.
Give me a prediction.
I actually would have thought this one would go faster because it's heavier.
Maybe it's that one. Maybe this one, yeah.
So you reckon this will be faster?
I reckon that one will be faster.
So why does that make it go faster?
Because the weight pulls it down quicker.
What are we measuring when we say, oh, it's heavier? What are we feeling?
Gravity?
Go ahead. Yeah, that's cool.
Objects being pulled to the earth, I guess.
Okay, so which of these objects is being more pulled to the earth?
This one.
That one, the black one.
All right. Well, here's what we're going to do. I want you to hold both of those above your head. Can you get them really high? Can you? Okay, on the count of 3. Ready? 3, 2, 1.
Yeah! Exactly the same.
They fell at the same time. Exactly the same time.
They hit at the same time.
Was that what you expected to see?
No.
So what do you make of that?
I need to go read more books.
Magic?
Gravity is going to pull at the same rate, no matter how heavy or how light it is.
But gravity is how light or how heavy something is.
There must be some force that's dragging them down, and actually the actual weight of it doesn't matter.
Something to do with mass or something.
I can't remember why.
It's almost like the weight holds it back in a way, even though that doesn't seem to make sense.
I think you might be hitting on an interesting point there. Weight holds it back. Now, it's not actually weight that holds it back, but inertia. That's the tendency of matter to maintain its state of motion, so to remain at rest if stationary, or to continue with constant velocity when in motion.
What's the big idea?
The big idea is this one has more mass, so it's got more weight, which you can clearly feel, but it's also got more inertia, which means it's also more sluggish.
Right.
It tends to resist acceleration. So that greater force is required to accelerate it at the same rate as this ball.
Like a heavy car trying to accelerate.
Like a heavy car trying to accelerate, you need more force to get it going.
Yeah.
Exactly. So what does all that mean? Well, the force on the medicine ball is greater than the force on the basketball, but it has more inertia. And what's really important is that the ratio of force to inertia is the same for all objects. So everything accelerates at the same rate and lands at the same time.
So, did you get it? What I want to make sure we understand is that when we're going ahead and doing our experiments for our egg drop, it really doesn't matter how much stuff you actually, as far as the mass of the actual container or our device. And the fact that they're the same shape really shouldn't matter either. Really what we have to focus on is acceleration, how to slow down that egg, and that's what's going to go ahead and make the biggest difference. So when you're thinking about your egg design, and when we're going ahead and taking a look at why certain designs are better than others, or why they were able to go ahead and have their egg survive, it all has to do with what's inside the device. What materials really help slow down the egg so that we have less acceleration, meaning less force on the egg. So that's what we're going to be paying attention to. Like I said, if you have questions, make sure you ask.